Hello. Hello.
Sir, good afternoon, sir.
Shivasankar. Everything
yes,
is
sir.
fine?
Yeah, yes, sir. It's going fine, sir.
Speaker
Join பண்ணிட்டாருங்க சார்.
ரைட். வேற எல்லாருக்கிட்டும் சொல்லிட்டியா?
இன்ஃபார்ம் பண்ணிட்டு இருக்கேன் சார்.
சரி. ஜாயின் பண்றேன்னாங்களா?
பண்றேன்னு இருக்காங்க சார்.
பாரு. இல்லைனாக்கா நீ டக்குன்னு ஃபோன் பண்ண 4-5 பேருக்கு. எத்தனை ஆயிருக்கு? 9, 4, 4, 8, 2, 10, 11 தான் ஆயிருக்கு. 12.
Sir, good afternoon.
Good afternoon, sir. How are you?
Sir, நான் செந்தில் குமார் சாம்பிள் சிசியன் எங்க டீம் 5 பேர் உட்கார்ந்துருக்கோம் சார்.
Very good. Share the photo, sir. Please.
Okay. Yes. போடு.
Supply, sir.
Sir, good afternoon, sir. Sandeep Kumar.
Good afternoon, sir.
Good
Good afternoon.
Good afternoon, sir. Mr. Gunasekharan, our lecturer, Mr.
Thank you.
Kumar.
Thank you, sir.
Sir, MC, our MD sir also is there joining, sir.
Very good. Welcome, sir. Sir, welcome for the video meeting, sir, video conference.
Durgapur சொன்னாங்க.
கம்பெனி பேர்
கம்பெனி இது
கம்பெனி Foundrymen
ஓவல் சார். நேஷனல் சென்டர் ஃபார் ஸ்கில் டெவலப்மெண்ட்.
இந்தியன் ஃபவுண்டேஷன்
இந்த நேஷனல் ஸ்கில் டெவலப்மெண்ட் சொல்லி
Good afternoon, fellow Foundrymen. We will start the meeting in another. We will start the meeting in another 2-3 minutes.
Okay, sir. Okay, sir.
ఇదంతా ఇదంతా అదే ఫ్రంట్
Sir, kindly unmute, sir. Sir, Dayalan, sir, you need to unmute, sir. Sir, no, sir, you are not unmuted, sir. Unmute, sir.
Right. Now I unmuted. Okay.
Yes, sir.
Sir, shall we start the meeting, sir? Yeah.
Sir, speaker, sir, you also need to unmute, sir.
Good afternoon, fellow Foundrymen. It gives me immense pleasure to welcome all the participants for this virtual program, which is being conducted by the National Center for Skill Development every month on the 4th Friday of every month. So in last month, we are unable to conduct the program due to the National Council meeting was held at Chennai. Because of that, we have to cancel the program and postpone it to this month. It is our regular practice to conduct a training program to the fellow Foundrymen, which is very much useful to them on the day-to-day practical life. So in this connection, we want to we invited Mr. Ashis Kumar Chowdhury, who is the ex chief scientist of CSIR, CMERI, Durgapur. He is very much specialized in the field of near net shape technologies manufacturing of engineering components. His contribution was as a scientist, Directorate of Aeronautics, DRDO, associated with the indigenous development of aero engines, MIG components through investment costing, forging, machining, heat treatment, and surface treatment routes. From 1991 to at most 1917, he was the scientist at the CSIR, CMERI Durgapur. executed various R&D projects in the field of NNS manufacturing, that is near net shape manufacturing technologies, and developed the following technologies: counter gravity, low pressure air melt sand casting technology, hot tempered ductile iron, which is normally called as ADI. The other one is the technology for epoxy bonded remagnets, and auto engine piston from high strength cast alloy with a superior high quality, high temperature, which ranges from 230 to 260 mechanical properties. Epoxy bonded CNT composite blades for drone application, and is what you call is adventures in the field of metallurgy and the field of engineering and casting manufacturing with respect to near net shape is which is very much high, so which cannot be what you call shortened in a short period of time. So with this small introduction, I request Mr. Ashis Kumar Chowdhury, who is the retired ex-chief scientist of CSIR, to deliver the lecture. Sir, the floor is yours. You can start the program, sir. Thank you.
Sir, please unmute. Ashis sir.
Sir, please unmute, sir.
Speaker, sir, please unmute your microphone. Sir, your voice is not clear. Sir, please unmute.
Sir, you unmute it and speak, sir.
Hello? Say.
All right.
Now it is
Now,
all right. Now you can talk. Sir, you have to
Okay,
start
now
from the beginning.
regarding. Good afternoon.
Good afternoon.
Now I start.
Good afternoon. Welcome, sir.
Okay. Under the program of Virtual Program 09 conducted by National Center for Skill Development, Chennai, today I am giving a brief talk on investment casting of engineering component. Casting is one of the oldest method of metalworking. The oldest known casting is a copper frog made 6,000 years ago in Mesopotamia. Common casting process is gravity casting, residential.
Sir, just a minute, sir. Sir, you present the screen, sir. Your screen is not visible.
You have to share now. That icon has not come.
Oh, wait, sir. Wait. I will share it. Otherwise.
Sir, please share your screen.
Sir, wait, sir. I will
Yeah,
share
wait,
it.
wait. See, he's doing.
Yes, sir. Now okay.
Yes. Good.
Proceed, sir.
Now it is clear. Please proceed, sir.
A full screen I have to give. Is it all right?
Yeah, all right, sir. You can talk now.
I am changing the screen, the slides. All right.
No, sir, I am changing it. You just speak it. You can
Okay,
speak, sir. I
okay,
will be
okay.
changing.
Okay, very good, very good. All right. Common casting process are gravity castings, residential mold casting, investment casting, pressure die casting. Today we'll be discussing only on investment casting of engineering component. Investment casting is the process of making intricately detailed near net shape casting. Its earlier use were for making of idol, ornaments, and jewelry. Essential elements were at that time was the natural beeswax for pattern, clay for mold, and manual operated bellow furnaces. During investment casting came into use as a modern industrial process in the late 19th century when dentists began using it to make crowns and inlay as described by Dr. D. Philbrook of Council Bluff, Iowa, 1897. Next slide. During World War II, that is 1940, there was increased demand for precision component of the specialized alloy that could not be shaped through traditional processes. Industries turned to investment casting process to manufacture the same in large volumes in NNS form. Today, it is one of the most important technology for the manufacturing of component for aerospace, defense, and medical sectors. Industry have already taken up the help of CNC machining, robotics, computer technology, and counter-gravity techniques to achieve the strict acceptance criteria of finished casting component for the above sector. Modern industry nowadays demands these two main things: high quality, complex geometry engineering component at an affordable price within a reasonable delivery schedule. Number two, in case of new products, the industry should be capable of delivering the prototype component as quickly as possible. Some of the engineering components being manufactured through investment casting process for different applications are as follows: orthopedic implants for knee joint, small gear for ordinary machine, trigger for firearm, and turbine blade for aerospace engine. Application of investment casting is limited to aerospace, firearm, military, automotive, agricultural equipment, power generation, textile equipment, medical implants, and dentistry and dental tool. There are a lot of advantages of the investment casting process. Some of them are easy to cast complex geometry component in large volume. Number two, provides excellent dimensional accuracy plus minus 0.05. Wide range of alloy can be processed. Excellent surface finish, easy to cast thin wall parts, low wastage of raw material, suitable for high melting point alloy, as well as difficult to machine alloys. Easy to achieve low level of inclusion content under vacuum melting and casting road, suitable to produce near net shape component. Now, when to select this process, IC process? The designer will select when complex geometry component having the right tolerance, tight tolerance, parts are non-symmetrical with the fine details, intricate internal passages in design, excellent as-cast surface finish is required, wall thickness is too thin for sand casting, machining of internal passages is not possible, alloy difficult to machine or process through other routes, high upfront tooling cost relative to sand cost are acceptable, high volume of production. The broad outline of investment casting: die making, wax injection, wax assembly to make tree, followed by slurry coating, followed by stuccoing, repetition of stage 4 and 5 till to achieve 6 to 7 layer of thickness, de-waxing to remove the wax, then melting and casting, followed by shell removal, cutting of the component, finishing, and inspection. Important step of investment casting is first you have to do the analysis of drawing and development of solid model, simulation of investment casting process, 3D model of wax pattern and ceramic coat, die assembly, manufacturing of die assembly for pattern and coat, then wax pattern and ceramic coat, assembly of pattern with the screw to form tree, preparation of ceramic cell, dewaxing, drying, and sintering of mold, melting of alloy and investment casting of component, fettling of cast component, inspection and testing of cast component, machining and heat treatment of final parts. Now, in details, I am going each steps of investment casting process. First, after receiving of the drawing and technical specification, the methoding department will analyze alloy specification and melting procedure, whether it is a air melting or vacuum melting, dimensional tolerance and dimension and surface finish. Accordingly, other things will be finalized. Inspection standard, DT and NDT, and defect acceptance criteria at different zone of the component. That is a very important thing in today's world. Once it has been defined, then next stage is development of solid model through computer of the as cast part. Incorporate the following in the solid model: complex hollow passages of the cast part, shrinkage allowances and machining allowances wherever it is very applicable. Create the solid model of as cast part and tree assembly. Initial simulation trial of solid model using data from library. Findings is shape, size, distribution, location of the defects of the casting. This is the shape, size, and distribution and location of the defects of casting. Okay. There will be a defect word here. To eliminate the defects, run more iteration for different cluster assembly using operating parameters like pouring temperature and mold temperature, pouring time, cooling rate, air cooling or slow cooling, then number of nodes and density of the casting. One thing will be always keep it in mind, number of nodes is very crucial to run this simulation. If the number of nodes are more, your computer time will be more. On the other hand, if number of nodes are more, you will be able to detect very fine defects. Now, that is why I have told in step 1, defect acceptance criteria in the different zone. Accordingly, you have to finalize. Suppose if you increase the nodes, you will get very, very fine defects locations by slicing the component in the computer. That has to be, decision has to be taken at the very beginning, which defect is acceptable, at what density, what distribution, what is the number. Now I'll show you two diagrams of simulations. One is in the left-hand side, there are small component assembled in a cluster of a tree. In the first row, it's 4, second is 3, and last one is 2. It is showing the solidification sequences of the component with respect to main reservoir of the pouring basin. The red color is showing liquid metal temperature. Green and blue is showing solidification sequences. On the other hand, in the right-hand side, it is the assembly of a turbine blades, stator turbine blades of a jet engine. There they have assembly on a one screw supplied by runner, 2 runners, one in top, another is bottom. And it is also showing the sequence of solidification. After completion of solidification time is over, then the methoding department should carry out slicing operation, whether any defect is there or not. And if it is there, what is the size and what is the location? Then in order to eliminate it, they have to run the simulation trial number of times. Generally, in order to achieve the target, 7 to 10 days time it will take to overcome these defects. Outcome of the computerized simulations are final geometry of the quality casting, geometry of pattern, runner, ingot, and their position, mold temperature, and pouring temperature, pouring time, solidification time, and cooling characteristics. Generally, this type of turbine blades are cooled under heat insulated box. On the other hand, some small component for general engineering purpose, air cooling is sufficient because shell mold itself is a hot condition. Computerized simulation is a new technology, but it is fast growing and industry standard to produce new product defect-free in the first time. Today, it is really versatile tool for particularly in R&D front. Next is manufacturing of die. Die for wax pattern. Solid model of pattern will give you the data. One way we can manufacture it through conventional machining stroke CNC machining. Otherwise, if it is a new product, we can go through RP model component and then silicon rubber mold for manufacturing of limited number of patterns to RP patterns. Type B is die for manufacturing of core. The contour of hollow passes of the cast component to be digitized from solid model, transferred to CNC machine, then metallic die to be manufactured through CNC machine. Template and gauges are used for periodic inspection of the die content. The material which are used for manufacturing of die assembly for pattern and ceramic core include steel, aluminum, beryllium, copper, rubber, and plastic. Soft metal tooling and non-metallic tooling RP are primarily used for prototype development. After manufacturing of die, you have to do the inspection. Die assembly has to be inspected for dimensional accuracy and profile by CMM. All working surface of the die cavity should be highlighted, should be highly polished. Desired surface finish to be achieved by polishing and lapping. Sharp corner are to be eliminated by easy ejection of pattern and pores. Trial runs are carried out with the die assembly to assess its performance for manufacturing of wax pattern and ceramic core. If necessary, before initiating final production. During regular production, periodic inspection of the die cavity has to be carried out with different type of tools and gauges. Manufacturing of pattern. Complicated shape of the closed tolerance, complicated shapes with closed tolerance and intricate core configuration demands the use of specific type of pattern material that should have the ability to reproduce fine details as well as can be easily removed from ceramic cell. Waxes. Waxes are mostly the preferred material for patterns and are normally used modified, blended with additive materials in order to improve their properties. Following waxes are maximum use. These are paraffin wax having the melting point 52 to 68, microcrystalline wax having the melting point to 63 to 93. Paraffin wax having the low cost, high lubricity, low viscosity. Microcrystalline wax, both hard, non-tacky grades as well as soft, tend to be highly plastic and provide toughness to the wax blend. Paraffin and microcrystalline wax are most widely used waxes and often used in combination because their properties tend to be complementary. The tank of an injection press holds the liquid wax and is constantly agitated to ensure homogeneous mixture of the wax. Hydraulic cylinder moves the liquid wax into the injection cylinder to prepare injection. Once die is closed, another cylinder, hydraulic cylinder, pushes the wax through the heated hose and into die via injection screw, filling the cavity, allowing the wax to solidify inside. Once solidified, the wax patterns are removed from the tool. Process parameter for making patterns: wax temperature, nozzle temperature, injection pressure, flow rate, and dwell time. A gate is left in the pattern which serves as the connection point for the wax runner in the next step of process. At this point, wax pattern are now ready to move for assembly with the screw. Wax have a low melting point and low viscosity, which makes them easy to blend, inject, assemble into cluster, and melt out without cracking the thin ceramic shells mold. Other pattern materials are plastic. General purpose grade of polystyrene is usually used for production of component in large volume. Points to be considered for selecting a pattern material: strength, fluidity, low ash content, compatibility with ceramic shell and core, dimensional stability, minimum dimensional distortion during storage as well as during preparation of ceramic mold, shell life, longer storage life, and miscellaneous is initial cost and availability. Pattern through RP. This is another way of making it. Advanced techniques have been developed currently to produce prototype when only a few patterns are required. For such limited use of pattern, rapid prototype pattern are being produced in machine utilizing advanced technique such as SLS, selective laser sintering, and SLO or SLO stereolithography, SLA stereolithography, with the help of special polymer called photopolymers. These techniques are also known as a 3D printing, produce prototype pattern after building parts by depositing fine layer of various material like ores and using laser only when necessary to achieve the finished shape as defined by CAD. These patterns have been found to have a favorable dewaxing response, resulting in substantially improved surface quality for investment casting prototype in many alloys. Prototype ceramic core are also being manufactured through RP route from 3D solid model. Manufacturing of ceramic core. Ceramic core are widely used in the investment casting to produce intricate internal passes in the casting. Ceramic core must have the following characteristics: enough strength to withstand the forces of wax injection, excellent thermal shock, resistance to withstand thermal stresses with high refractoriness, value to retain geometry during entire process, chemically compatible with the cast alloy, easily removable from casting. Investment casting core are two types: one is self-formed cores and pre-formed cores. Self-formed cores require that wax pattern already have a clear opening corresponding to the passageway desired for casting. For simple shape, this is achieved by using metal insert or stroke pull cores in the pattern tooling before injecting the pattern material. First one is a wax pattern with self-formed core. Second one is cluster produced from the same pattern. Source is given. For example, for complex geometry where pulling of insert is difficult, soluble core are placed in tooling and then wax injected in to make the desired pattern. Soluble cores are generally made from the solid polyethylene glycol with a powdered filler such as sodium bicarbonate or calcium carbonate. The filler can be dissolved in aqueous solution, citric acid, with a vigorous gas evolution providing the agitation to speed up the dissolution process. Then first one is preformed cores. Preformed cores are required when self-formed cores cannot be used. Simple tubes or rods are commonly extruded from silicon glass. Many cores are made by injection molding of fine ceramic powder, fused silica, and sometimes with the addition of jargon with a suitable organic binder thermoplastic material like polyethylene ethyl cellulose into steel die, subjecting the cores to two stages of heat treatment. In the first stage, thermoplastic binder is slowly removed from the cores without disturbing the core geometry. This is very, very crucial technique. In the second stage, the core is sintered at high temperature to achieve its final strength and dimension. Preformed cores are normally used by placing the pattern die and injecting wax around them. Since core expand differently than shell mold, due to their difference in composition, core must be provided with slip joint in the mold. Dimension of core print and dimension of seed mold should perfectly match, leaving no gap in between. Displacement stroke breakage of the core has to be prevented during injection of pattern as well as during casting process. Otherwise, casting will be defective one. In order to ascertain the dimension, it is easy to measure the gap between the wall of the core and die cavity with the help of template stroke gauge. This has to be performed after placement of core inside the die cavity. Cleaning of pattern. Currently, Foundry practices for cleaning and etching wax pattern for removal of silicon oil or any other releasing agent before primary ceramic coat is applied. Includes use of citrus-based solvent, detergent emulsion, a mixture of both. Otherwise, it will be difficult if we are not removing the greases and silicon oil, difficult to carry out the shell making. Pattern was of this type have been replaced. The dangerous low flash points of solvent which were earlier used, spirit, acetone, toluene, xylene. Current formulation of water-based solutions, dilutable and with a deionized atom and recyclable. These are more useful and easy to operate. After washing or blowing off, often with the air, the solvent is left to evaporate clear. The effectiveness of the cleanliness of the pattern surface has to be inspected by carrying out the test. Dip a clean wax bar or pattern into primary binder slurry to its midpoint. Remove the binders and observe the surface. Good wetting indicators would be uniform coating with a no slurry break. Poor wetting indicators include slurry breaks and forms holes. Now next is coming is runner design. Runner distribute the liquid metal to optimize the metal supply mechanism. It guides the liquid flow to fill the targeted product cavity. Also, it allows multiple metal delivery channels, which enables a mold to hold multiple products cavity. This adds economical value to foundry practices. Adding more parallel runner can also help to facilitate better metal filling in a complex or heavy parts. Size of runner also influences the feeding rate into ingot, which later relates to the feeding rate into the product cavity. Preparation of pattern assembly. Design of the pattern tree or cluster is a critical and important matter since it can affect every aspect of investment casting process. It is typically uneconomical to make small parts one at a time. So wax patterns are typically attached to wax screw. Screws serve two purposes. Provides a mounting surface to assemble multiple patterns into single mold, which will be later filled with a molten metal. Provides a flow path for molten alloy into mold void created by wax pattern. Then gates. The wax between the pattern and screw are called gates because they direct the flow of the molten metal. The gates serve functions, several functions. To attach the pattern to the screw of a runner and form cluster to provide passages for draining out pattern material during dewaxing, to guide molten metal entering the mold cavities in the casting operation to ensure sound part by feeding the castings during solidification. Here I have given the photograph of two examples. This is a typical small component. First one, solid model of a small component. Next figure is this one is solid model of the component with ingot. Red color is ingot. In the next photograph, the entire all these components, 12 components, left hand side 6, right hand side 6, central sprue, and in the top of it is a pouring cup. Bottom is feeder extension. This is the height of the feeder. The right hand, extreme right hand is a indication the location of runner. Entire cluster is having 36 parts. Since this is small, this system can take the 36 part in one time for one-time casting. So this has to be, by experience, one has to decide how many parts has to be assembled in the tree. If the height of the feeder is more, then there is a tooth factor will come into picture. One is weight of the entire system will be very high, including weight of the shell mold. Second is, if the height is increasing, there is a tendency of turbulence at the bottom of the mold. So it is not desirable because it will erode the shell layer. So there has to be optimized design factor. On the other hand, the corner one is another single component, integrated single component of hollow vent turbine. Here it is an integrated integrated turbine of stator turbine. It is assembled in a ring. So it is having 3 runner, 1 sprue, 1 pouring bus, and 1 vent hole. Vent hole is giving the passage of air to come out from the during pouring of liquid metal, so that air should not be entrapped. So by this example, one can understand what would be the assembly criteria for sprue and ingots, how it will be assembled. Large patterns are set up and processed individually, but small and medium ones are assembled into multiple pattern cluster for economy of the processing. Most patterns are injected complete included in the ingot. However, complex parts can be injected in segments which are assembled into final form. Gating components, including pour cups, are produced separately. Patterns and gating component are assembled to produce the pattern cluster. Preformed ceramic cups are often used in place of wax one. Assembly of all parts are done manually. Wax components are assembled by wax welding using hot iron on spatula or small gas flame. Wax at the interface is quickly melted and components are pressed together until wax reaches solidified. Joint are smooth over. Subsequently, it will be, you have to, at the center radius of corner has to be filled up with the wax. Pattern must be properly spaced and aligned. Joint must be strong and completely sealed with no undercut. Polystyrene pattern can be assembled by welding, such as methyl ethyl ketone. The plastic at the interface is softened by solvent and parts are pressed together until bonded. Assembly of polystyrene to wax is done by welding with only the wax being melted. Cluster design. Factors to be considered for designing of pattern cluster are easy to assembly, number of pieces to be assembled, handling strength, easy of mold, form and drying, flow of liquid metal, feeding of shrinkage, fettling, and available infrastructure. Means size of the furnace also is a big factor. 3 requirements are essential: providing a cluster that is properly sized and strong enough to be handled throughout the process, meeting the metallurgical requirement of the component, casting of separate test specimen for chemical and mechanical tests. Once these essentials are satisfied, other factors are adjusted to maximize profitability. However, countergravity castings process and directional solidification process demand different type of cluster design. Pouring cup. It collects the pouring liquid metal and facilitates metal flow into the mold. It is the liquid metal entrance into the mold. In advanced casting, it also acts as a reservoir to supply extra metal if required. Proper system design can also, proper gating system design can also trap slags, dross, and inclusion from entering the product cavity. Light inclusion floats to the pouring cup given enough time due to lower density compared to liquid metal. They may present in the mill or and form during pouring. Reoxidation is the most frequent origin of inclusion. Some inclusion can also originate from melting and casting equipment from the furnace and ladle, even from the mold debris. This has to be carefully handled. Ceramic shell molds are made by applying series of ceramic coating on the pattern cluster. Each ceramic shell consists of 7 to 10 layers of ceramic particle layer. Most common refractory materials which are being used for ceramic shell mold are silica, zircon, various aluminum silicate, composed of mullite and free silica. Alumina is being used for production of superalloy casting. Silica is used in the form of silicate glass. Its extremely low coefficient of thermal expansion, in part thermal shock, resistance to mold, and ready is soluble in molten caustic soda. And caustic solution provides a means of removing shell material chemically from inaccessible area of casting that are difficult to clean by other molds. Zircon occurs naturally as sand, and it is used in the form as stucco. It is generally limited to use. It does not occur in a highly size required for the backup coat. It is sometimes also used with a silica and or aluminum silicate. Its advantage is high refractoriness, resistance to wetting by the molten metal, and round particle shape and availability. That is why fast coat of the shell is made by zircon powder. Alumina is more refractory than silica and mullite, or less reactive towards mini alloys. Its use is primarily confined to superalloy casting. Selection of shell material is dependent on the number of parameters such as type of alloy, temperature of pouring, casting process, and availability of cost. Availability and cost. Some of the typical refractory materials and their maximum use temperature are: alumina can be used up to 1840, silica 1680 degrees centigrade, zircon up to 1650 degrees centigrade, aluminosilicate 1560. Ceramic slurry generally consists of fine-grained refractory flower particle size 200 mesh, that means 70 to 80 micron, or fine, in a binder of ultra-fine silica particles. First particle is 70 to 100 mesh, 200 to 125 micron. Second, third layer is 50 to 90. And fourth subsequent layer of particle size and particle size is 10 to 40 mesh. Slurry are prepared by adding refractory powder to the binder liquid, using agitation to break agglomeration, remove any air entrapment, and treatment. Continued stirring is also required in production to keep the powder from settling out of the suspension. Either rotating tank with a buckle or propeller mixture are used for this purpose. Control procedure for slurry vary considerably among foundries. The most relevant controls are measurement of initial ingredients, slurry temperature, density, pH, and viscosity. Viscosity is measured with the number 4 to now or number 5 Zancop. Properties of the finished ceramic shell that are monitored include permeability, strength, and weight. These three are very important parameters for ceramic shell. Role of binder, stability and rheology of ceramic slurry, green strength of shell, high temperature strength of the shell, normal slurry contain colloidal silica, ethyl silicate as a primary binder. Both provides an extremely small particle size that is evenly distributed around ceramic aggregates. Silica particle size ranges from 30 to 80 nanometer. This silica particle size is 70 to 80 nanometer is a very important thing for binding. Small particles provide very large surface area, which because of its high reactivity produces excellent bond in the both green state and fire state. Small amount of organic material are also added in the binder in the slurry to improve pattern weighting, reduce foaming, and increase grain strength. Typical composition of zircon slurry, which is being used as a first coat material, basically it will be there always binding. Colloidal silicon 9.5 liters, water 3.4 liters, zircon powder 45 kg. Density should be around 2.7 gram per cc, viscosity 8 to 10 number 4 cup. Slurry are prepared by adding refractory powder to the binder liquid using agitation to break agglomeration. Remove any air entrapment. Stirring is continued until viscosity falls to its final level before the slurry is put to use. Continued stirring is also required in production to keep the powder from settling out of suspension. Either rotating tank with bottle or propeller mixture is used for this purpose. Small addition clay bentonite, very small amount, improve coating characteristics. Weighting agent sodium alkyl sulfate 0.03 to 2% weight of the liquid may be added. Hybrid binder. The colloidal silica, ethyl silicate can be added together to produce better binding. Water required for hydrolysis of ethyl silicate is supported by using colloidal silica, providing additional source of silica particle for improving the strength. Composition of slurry, which are usually proprietary, are based on the particular refractory powder and type of binder. Slurry composition is generally in the following range. Binder solid 5 to 10, liquid from binder are added 15 to 30%, and refractory powder 60 to 80%. Pattern cluster is first dipped into the ceramic slurry bath, then cluster is withdrawn from the slurry and allowed to drain out the excess slurry. And to produce the uniform coating of the slurry on the surface entire assembly, wet layer is immediately to coat with a different grade of ceramic particle, either by sprinkling of the particle or by immersing it in the fluidized bed of ceramic particle. First layer, fine ceramic powder, that is zircon powder, are uniformly sprinkled over the entire surface of the tree assembly. After drying, additional coarse ceramic particles are gradually embedded layer by layer over the cluster assembly. After each layer, the assembly is dipped in the ceramic slurry bath and then sprinkled with coarse ceramic particles. A total of 7 to 10 layers of ceramic particles are added to form the total layer. This thickness depends upon the weight of the component, particularly, and density of the material. These are the two factors has to be decided. Handling strength is the one of the factors. Rate and uniformity are important parameters in drying the ceramic molds. Are very critical since variation during drying can cause the pattern to distort, leading to improper function of ceramic layer. This drying is a very slow process. In order to maintain uniformity, the environment has to be always safe. It is desirable to use drying cabinet to maintain stability despite the cooling associated with the evaporation of water. This can actually crack the coating. Therefore, to prevent this, relative humidity is normally kept between 40 to 50%. Between coats, slurries are hardened by drying and pickling. Number of coats required to related to the size of the cluster and to the metal weight to be poured. It may ranges from 5 for the small cluster, 12 or more for the larger one. Most application, number varies between 6 to 9. The removal of pattern dewaxing from ceramic mold. Pattern removal is the operation that subjected the shell mold to a most stressed one, since thermal expansion of the wax are many times those of refractory used in the mold. When mold is heated to liquefy the wax, expansion differential leads to enormous pressure that is capable of cracking the mold. In practice, to minimize the stress due to expansion of wax, heating of mold is carried out extremely rapidly from the outside. This causes surface layer of the wax to melt out very quickly before rest of the pattern can heat it up appreciably. This molten wax layer either melts out of the mold or soak it in between, thus providing the space to accommodate the expansion of the wax as the remainder wax is heated. Before dewaxing, ceramic shell are subjected to 16 to 48 hours extended drying after the last coat for complete removal of moisture and achieve the full strength, which can withstand the stresses. Two methods are developed for implement to surface melting concept to drain out the pattern material: autoclave dewaxing, high temperature flash dewaxing. Autoclave dewaxing, a most widely used method, saturated steam is jacked vessels with a steam accumulation to ensure rapid pressurization. Autoclave are equipped with a sliding tray to accommodate number of molds. The fast-acting door with a safety lock and an automated wax drain valve. Operating pressure is 550 to 620 kPa or 80 to 90 psi, and reached within 4 to 7 seconds. The mold are dewaxed in approximately 15 minutes or less. High temperature flash dewaxing is being followed for removal and burning of polystyrene pattern. Autoclave removes the majority of the wax, which can be reconditioned and reused. Flash fire burn of residual wax and cure the shell, ready it for casting. Mold firing and burnout. Ceramic shell material are fired to remove the moisture, combined to burn off residual pattern material and any organic used in the slurry material, shell slurry, to sinter the ceramic and to preheat the mold to a temperature required for casting. In some cases, these are accomplished in a single firing. In other times, preheating is performed in the second heat. After mold is cooled down and inspected and repaired if necessary, cracked mold can be repaired with the ceramic slurry or special type of cement. Sometimes mold are wrapped with the ceramic fiber blanket, that is slow cooling, or placed in the insulating box to minimize the loss of temperature that occurs between preheat furnace and the casting operation, to ensure better feeding of molten metal in thin section of the mold. Preheat temperature vary depending on the part configuration and alloy to be cast. Aluminium preheating requirement is 150 to 6540. Copper base is 425 to 870. Steel and superalloy between 850 to 1050. It is essential to measure the temperature profile inside the furnace where the shell will be heated. Regularly, it has to be measured. Variation of temperature across the hearth of the furnace should be within ±5. Rate of heating should be very, very slow to minimize the thermal shock, thermal stress on the ceramic shell. Melting and casting. Investment casting units operates induction melting furnace to process various types of alloy. Most induction furnace for investment casting have a capacity ranging from 25 kg to 250 kg. Induction furnaces can be employed for melting in air, vacuum, or inert atmosphere. They are extensively used for melting of steel, iron, cobalt, nickel alloy, and sometimes copper and aluminum alloy. Crucible typically used are magnesia, alumina, zirconia. Most of the engineering components are made through air melting and casting. After reaching specified temperature, liquid metal is tapped in the ladle. During pouring from a ladle, it is preferable to pour the liquid metal from a minimum distance and height, slowly and continuously. It will ensure non-turbulent flow inside the mold cavity, essential for producing high-quality casting. This photograph is highlighting what will be the distance. It has to be maintained. Vacuum melting and casting provides a cleaner metal and offers superior mechanical properties. Its major use is for special type of alloy, like nickel-based alloy, cobalt-based alloy, and titanium. A major advantage of investment casting is its ability to cast very thin wall casting due to use of hot mold. This advantage is further enhanced by specific casting methods such as vacuum assist casting, pressurized casting, and counter cavity casting. These are 4 types of counter cavity casting process known as acronyms CLA, CLV, CV, CLS. This is another technology extension of investment casting technology. In order to meet the stringent acceptance criteria of jet engine component like turbine blades, Richner International US developed the counter gravity casting during 1975 to 80. Counter gravity low pressure casting of air melted alloys is popularly known as a CLA. CLA has the preheated ceramic mold with an extended screw placed in a chamber above the melt of an air melted alloy. The screw is lowered to below the melt surface. Vacuum is applied to the mold chamber to cause the controlled filling, anti-gravity filling basically, controlled filling of the mold cavities. Vacuum is released after the casting and the ingot solidify, causing the molten metal in the central screw to return to the crucible of the furnace for the next cycle. Advantage of this one is low intrusion level, higher yield, easy to cast in section, easy to remove parts from during fitting. Other process name is CLV, counter cavity low pressure casting of vacuum melted alloys. Here it is a melting should be done in vacuum. Check valve system, CV system for thick component. CLAS, counter gravity low pressure air melted sand casting. CLV and CV uses ceramic mold, but CLAS uses heat cured sand mold system. This is the diagram generally available in the handbook. Counter gravity low pressure, here it is showing this is the first stage, inverted condition, just reverse inverted condition of ceramic molding. red hot ceramic mold is placed inside a steel box. And from here, it will come down to the liquid metal. This sprue will go inside, just below the first layer, so that inclusion is not going inside. Liquid will be drawn from the central portion of the melt. So always you will get very clean liquid. And since control of suction, you can, if according as per the application of pressure rate, suction rate, the flow will take place. Therefore, turbulence is totally eliminated. Once it is filled up, the chamber is totally filled up, the vacuum, the in-gate system will be solidified and pressure is released, the central sprue will go down. The liquid from central sprue will go back to the furnace. Then component will go, the box will go up. Here, the main critical things is in-gate geometry design and box rotation. So this is a very unique process and being used till today in USA. Extension of this process is CLV. This is your melting is done in the vacuum, and then once vacuum melting is over, it is going up and the box is coming down and suction is taking place. The casting is over. The furnace, melting furnace will come down and the box will go up. This is mainly suitable for reactive alloys like nickel-based alloy and titanium-based alloy for aerospace component and medical implants. Advantage of counter-gravity casting process, yield is 7 to 90%. It is not possible in normal investment casting, but in the CLV, it is possible. Non-turbulent flow of liquid metals. Far less slag and non-metallic inclusion, 80% less than conventional gravity casting. It is really significant output. Ability to cast thin section, easily superior quality and low rejection rate. Since defects are very low, inclusions are also low, automatically, consistently, you will get higher mechanical properties, suitable for both ferrous and non-ferrous alloy. Now, next, another development has taken place in the last 20 years. Metal parts with a complex geometry. When we are not able to produce by conventional die wax injection method, the fins are very thin, which cannot be ejected out from the die, then 3D printing machine has come into picture. 3D wax printing machine can deliver complex geometry wax pattern for the creation of intricate metal parts with a complex geometry through investment casting route. Specialized wax material are available for 3D printing that are designed for the clean burnout and compatibility with a different metal alloy. The first one is showing the green color wax by 3D printing method. Second one is showing one component green color wax pattern followed by a ceramic mold with a basin, and final right hand side is showing the component. Okay, ceramic mold and cast component. This process eliminates the need for traditional tooling dependent pattern making it suitable for prototyping, spare parts, and short production run. Advantage is initial level, whenever new product is being designed, you will get a lot of design flexibility, high accuracy, high surface finish, rapid prototyping, cost and time saving. Only thing you have to incorporate 3D printing machine in your production line. Application is the fast changing sectors are aerospace and automobile. Medical is customized implant you can do, and jewelry also is another sector. Post-casting operation. Post-casting operation represent a significant portion, often 40 to 50% of the cost of producing investment casting. Standard shop routine is provided for each. Large savings can be revitalized by specifying the most cost-saving route. Knockout, Shell material is knocked out with the vibrating hammer or by hand. Remaining portion of the shell and layer of the prime coating adhered to surface casting are removed by shot blasting. Fettling aluminum, magnesium, copper alloy are cut off by sand from harder alloy removed from the ingot with the help of abrasive wheel. Following cut-off, gets tough and ground flush smooth using the abrasive wheel. Core removal. Core can be removed by abrasive or by water blasting. If water blasting is not possible, core can be dissolved. This can be accomplished by molten caustic soda and or boiling solution with 20 to 30% sodium hydroxide, potassium hydroxide is an open form. Heat treatment operations are carried out as per the standard cycle applicable for the component. Subsequent blasting is also carried out to remove the scale resulting from core removal and heat treatment. Then components are released for final machining. Inspection and testing as per requirement can be done. Chemical composition, visual inspection, NDT, X-ray, dimensional inspection, and DT, hardness, tensile, stress, and rupture metrography as per is international standard. Guidelines for production of high-quality investment casting to be followed. Carry out simulation with a wide range of options and parameters and select the best one. It will minimize the chances of rejection. Implement the outcome of the simulation to the extent possible. Die assembly to produce as per silicon solid metal of the pattern. Die assembly to be inspected for every details. Carry out the trial runs for die assembly, inspect the pattern, and then clear the production. All raw material to be procured as per specification from reputed vendors. Wax patterns with surface defects or distortion should not be cleared for next operation. Viscosity of ceramic slurry should be checked regularly with gel cup. Wax pattern and pattern assembly have to be stored in a controlled atmosphere. The surface of the wax pattern to be cleaned and with the solvent to remove oil and grease and dirt. During ceramic coating of the wax assembly, sufficient time should be given to dry each layer of the ceramic coating. During burning of residual wax, slow heating of ceramic shell is recommended. All furnace to be regularly calibrated. At the time of pouring of molten metal, the pouring basin of the shell mold is to be placed nearer to the spout of the furnace or nearer to the spout of the ladle. Guidelines may be followed for making the pattern cluster. Gates should be placed on the heaviest sections. Ensure all isolated heavy sections at the gates and feed path. Ensure gates are located where parts are dewaxed without tapping the wax in the isolated cavity. Locate the gates in the non-critical location of the part if possible. Ensure gate 2 is located in an area where it can be easily cut off and ground size. Place gates away from the ports if possible to minimize obstruction and pressure in the flow form. Conclusion is investment casting has withstood the test of time, providing its value across the 1,000 years. Indeed, it is still being developed to meet the demand of the modern society. Even in the modern age, it remains a cost-effective, efficient, environmentally responsible method for producing precision metal components. Industry have already implemented advanced tools like CAD, CAM, simulation software, automation, robotics in the production line. Software tool not only reduce the development cycle, but they are also give the opportunity to manufacture high quality casting at a competitive price. And it also helps minimize the rejection rate of the product. I have shown you here 6 components. Chola casting, which was developed long ago, still it is being used in the cottage industry and small scale industry. For large number of people are involved in this. Trigger is our defense people are using for armament. Small gear is general engineering. Hollow turbine gears and the hollow vane is for aerospace. and orthopedic implants at present, cast orthopedic implants are being imported in India. Thank you. This is the end of the lecture.
Yeah. Good evening, fellow Foundrymen. Is there any questions to be asked or doubts to be clarified? They can ask.
Sir, I have one question.
Yeah, please continue.
Please continue.
This wax, what is the ash content is control limits is required? The wax to be used for patents.
You see, wax should be as low as possible. If you procure it from standard market from Bombay and other place, good vendors will always recommend, tell the ash content as low as possible. Why I'm telling it? If wax is sticking in the different location of the ceramic shell, okay, then the inclusion will go inside the liquid metal. So you have to take the certificate from the wax supplier, and preferably the virgin wax has to be.
We should have given one specification to them, to control that ash.
If you have to check it, and preferably good quality wax has to be introduced every time, and it has to be blended with the other thing. And if you are getting too much this one, what is called ash content, you will get problem in the component.
Okay.
This is the main thing.
Now, the basic problem is when you have to buy a wax from any vendor, we need to specify some ash content. So that specific requirement, I mean specification is required to put in a standard. So that's why I'm asking the intent of that question.
Yeah, since you are in the production line, it is better you refer to specification of wax. There are a lot of wax specifications. If you are going for normal, suppose for discussion I'm telling, idle, okay, the normal static item, you can take any wax. There is not so hard and fast. Now, if you go for dynamic, it is well defined in specification. If you go to mill specification, aerospace specification, mill specification, then you will get details how much is allowed. IS specification, for which purpose it is being used. This raw material, whatever I have told you, whether it is a wax, whether it is a sodium silicate, whether it is a silica gel, this one, all these things have a specific quality. Few years, about 2 years ago, I went to some industry in Hyderabad area. So they have reported me that there is a lot of inclusion in the component. Then I asked them, where from you are getting raw material? Raw material of sand, raw material of wax, raw material of a binder, everything is having international specification. If you get it, you will be clearly getting which material you want. There are very few vendors in India who is able to maintain the standard. That is, if you mix it with an ordinary type of wax, you will land into trouble. Because if you want to maintain an international product, you have to go to international wax. Because whatever I have developed during my time in rare earth material, I have imported everything from different places. It is not available in India. But technology is available, but you need to introduce your raw material from outside.
Sir, I have one question.
Please tell me.
Sir, in your one slide, you mentioned that proper gating system, if you will establish in this process, until and unless slag and inclusion will come. So how it is possible, sir? If I will maintain the proper gating system, it is okay, sir. If before that process our coating and other thing will not in a proper way. So slag and during melting time, I know very well ki if you will not care of remove the slag, so slag will come out.
No,
so proper system.
Let me complete. Removing of slag at the furnace is one step.
Yes.
Removing of slag, removal of slag in the furnace is one level.
Yes.
Now, from slag, most of the cases, you are tapping it on a ladle. Okay.
Okay.
As soon as you tap it in the ladle, churning will take place. Okay.
Okay.
This churning, we do not give the importance to it. It is having two effects. One is it entrap the air and reoxidized.
Okay.
Second phase, when we are pouring on the basin, that is called pouring basin, if it is not properly designed, it will also churn and it will create a turbulence inside the surface. Now, question is, if we do not maintain proper design of inlet, suppose it is
Yes.
sharp corner is there. If sharp corner is there, I heat it in the furnace, it will crack. I have to blend it. Radius of curvature should be very low. Stress should be very low. Because thermal stresses which you do not able to see, it is having big impact on the final product. Investment casting is no doubt is a very unique process, but one has to be very careful. Entire route has to be followed with proper science and technology guidelines. If you sacrifice anyone, you will land into trouble. Your
Okay,
rejection rate will be high.
Sir, one other question. If I will compare this process to lost form casting, vacuum lost form casting, so how can I say that ki vacuum lost form casting and this process, investment casting process, which one is better and which one is
Investment
more
casting is
precaution
Investment casting is much better.
than vacuum lost form casting, sir?
No, I'll tell you.
Yeah.
In the vacuum, your lost form, your mold is at room temperature. Am I right?
Yes.
Now, as soon as you are going to room temperature or slightly temperature related any mold, and shell mold temperature is 1000 and above,
Okay,
your
sir.
fluidity will be much easy. In thin section, whenever the liquid front is moving, the front area, thin section, the air entrap will be going out of the permeable layer of the ceramic mold easily. Okay. Its movement will not be restricted. That is why any thin section component, complex geometry component, will be always going in the investment casting line.
Okay, sir. Okay, sir. Thank you. Thank you so much, sir.
Hello, sir.
Sir, I
we
have
a
one question, sir. Sir, in investment casting, sir, what the shrinkage allowance percentage is required, sir?
Your question, you tell me again.
Sir, shrinkage percent requirement in investment casting, sir.
Into contraction
Such.
allowances.
There are two. You tell me. You give answer. Now I'll give you the answer. Shrinkage are two places. One is machining allowances, solidification shrinkage, and normal sand casting. We are having pattern shrinkage. Okay, the three. Here, the pattern shrinkage is minimum. Okay. Now is coming as a solidification shrinkage. It depends upon the amount of the liquid from which liquid metal you are using it. Aluminium is one type, cast iron another, nickel base is another. Accordingly, the component compositions will dictate the shrinkage level, which is available in metal handbook. You got my point?
Yes, sir. Yes, sir. Thank you.
Sir.
Hello.
Sir, one question, sir.
Tell me.
Yeah, sir, I wanted to know that what is the major market when it comes to investment casting?
Means which market you want to know?
Sale, in terms of sale.
You see, till date, huge market is available for defense sector, automobile sector. Okay. Huge market.
Okay.
Medical implants technology is not available in India. That is another sector is coming up. But in India, that level of technology is not available. Okay.
So in military equipments and what else?
You can tell me?
Military equipments and what else? In what components?
You see this medical line you are telling?
Medical or military, like armed forces, I think.
Armed forces, they are in military defense sector, there are a lot of plant already existing. Okay.
Okay.
As well as
Okay.
now the government of India is going to the private sector. Okay.
Okay.
So if the people are able to maintain its quality of and process parameters within the limit, they will be able to achieve the target. Otherwise, very difficult. Because both defense and aerospace now, factor of safety is very limited. So acceptance criteria is very tight.
Okay. And what about the medical components, like what components are made when it comes to investment casting in medical field?
Medical equipment, medical component is, suppose you are taking the all knee joint, okay, suppose what they take, it can be manufactured from cobalt-based alloy or from titanium. For these two, you need a separate type of furnace. Normal induction melting furnace will not work because it is not the strength is the criteria. In medical, surface inclusion is not at all acceptable. Okay, surface finish should be of the highest order. So normal air melt quality cannot solve the issue.
And the aerospace equipments and military equipments, the induction furnace can be used.
There you can use it, induction furnace. Air melt is possible.
Okay, thank you, sir.
Thank you.
Sir, we have one question, sir. Sir, in selling room, selling area, sir, normally, what is the temperature and humidity range, sir, we should maintain? It's a standard selling area, coating area, sir.
Coating area?
Yes, sir.
Coating area, you have to maintain the air conditioning system, full air condition.
Okay, sir.
Means 24 degree or plus minus 2 degree.
Okay, sir.
And moisture 50, 40.
40 to 50, yes, sir.
That level. You see, because I have started my career in defense, there I have observed this impact on the hollow turbine blades. Okay. That is why I am very much confident how to implement it. Okay.
Okay.
Because you have to follow all stringent, even after joining in the CSIR, CMERI. The way I have brought this success in shop floor, I followed the science and technology ditto. Whatever is coming out from the simulation, I will implement it. No compromise. No compromise.
Okay, sir.
Sir.
Sir, and also one more question, sir.
Sir, yeah.
Titanium-based
Sir.
alloys, sir.
Sir, 1 minute.
Titanium-based alloys. Can we process in vacuum induction melting, or we need to go for skull melting, sir?
Preferably skull melting.
Okay, sir.
Once I got the offer to buy a skull melting furnace, so for making the medical implants, the cost of 10 kg furnace is 10 crores at that time. Only furnace.
Okay, sir.
So those who can afford it, they can buy it.
Okay. So what is the difference between a vacuum induction melting and skull induction melting, sir? What is the product advantages, sir?
If you go to literature, you will find this diagram. The fundamental difference is it is a copper crucible. Okay.
Okay, sir.
Skull melting furnace is having a copper crucible and it is a cooled from the bottom. Okay.
Okay, sir. Okay.
Once the melting started, within 15-20 minutes, liquid metal will take place a semi-hemispherical surface. It will not touch the vertical wall of the crucible. Melting is over, immediately you have to pour it. Because if it is titanium, its melting temperature is about 1600, 1500 degrees centigrade. If it touches copper crucible, its solubility in titanium is very low. And if it touches, the crucible will go. So that is why once melting is over, you have to tap it.
Okay. Okay, sir.
Okay.
Sir, Rao, sir, you are having any questions, sir? Rao, sir? Dear participants, if any other question is there? Yeah, okay. Sir, join பண்ணிடுறீங்களா sir? Yes, sir. Sir, just a minute, sir. Dayalan sir is joining.
Okay, no problem.
Sir,
Good evening, sir.
one more question, sir.
Sir,
Sir, in nickel resist type 1 grade material, sir, what is the temperature, preheating temperature and melting temperature, sir?
I could not get your question. You tell me.
Sir, for nickel resistant type 1 grade materials, what is the nickel resist? Nickel resist.
No, you specify. That is not a material specification. You tell me.
So starting and the SAP choose combine option. So அதுல TP நம்ம வச்சிருக்கோம். Test TP ஒன்னு live TP. Live இப்போ லாக்
இப்ப கிடையாது, நம்ம டெஸ்ட் மட்டும்
டெஸ்டிங் ஒர்க் பண்ணனால ஒர்க் பண்ணிட்டுங்க. நெக்ஸ்ட் நீங்க 1ஆம் தேதிக்கு அப்புறம் டெஸ்டிங் உங்களால அக்சஸ் பண்ண முடியாது, லைவ் மட்டும் தான் ஓபன் பண்றீங்கன்னா கொடுத்து. இப்போ டெஸ்டிங்ல கிளிக் பண்றாங்க.
Sir, yes, sir. Dayalan sir. Sir, Dayalan sir.
Yes, sir.
Sorry.
Yes, listening, sir.
Sir.
Sir, shall we go for vote of sir?
Yes, sir. Yes, sir.
Yes, thank you. Sir, we sincerely thanks Mr. Ashis Chowdhury for his august presence in this meeting, and he shared his in-depth knowledge in the field of foundry industry, and as well as the knowledge what he is having is really it is abundant, and then only he was able to share only the minimum through this 1 hour session. So what I request all other members are, kindly take his number, take his personal contact number. You ask him to come to visit your factory, share his knowledge, and as well as the experience what he has gained with DRDO. It will be highly useful to the foundry industry. Along with this, I sincerely thank all the participants and who are all able to express or ask more questions about in the foundry industry. And as well as it is our regular practice to conduct the meeting regularly on 4th Friday of every month. And I request everyone to join for the next month meeting also. Thank you very much. Thank you, sir. Thank you, Ashis sir. And thank you all the participants. Thank you very much.
Thank you, all of you.
Yeah, thank you. Very kind of you, sir. Thank you.
Thank you, sir.
Thank you. Thank you. Cut பண்ணிட்டா?
Okay, sir.
Thank you very much.
Okay, sir. Okay.
Okay.